Welcome back, my friends. A very good morning, good afternoon, good evening to all of you. I am Raghunandan Sengupta from the IME department, IIT Kanpur, and this is the TQM 1 course. And today is the 19th lecture where we are discussing. If you remember, we ended yesterday about sequential sampling, the plans of double sampling, how it can be extended to sequential sampling based on the stopping rules, stopping criteria, all these things. Qualitatively, obviously, stopping rules and stopping criteria, if you remember, I did mention that they would depend on the distribution, what plans you have, and all these things. So, to continue the discussion, the examples of sequential sampling plan is like this. Now, you basically consider the number of defects. So, number of defects in a lot. So, in the general sequential sampling is that you pick up n, then check the stopping criteria. If the stopping criteria is met, you stop it. If not, you proceed, and that procedure to consider whether one observation or more than one observations in at one go would depend on what plans which you have. There are different sequential sampling plans which we know in literature. It is not part and parcel of this TQM course, but I would like to mention they are the purely sequential sampling plan, then the 2-stage sampling plans, 3-stage sampling plan, accelerated sampling plan, batch sequential sampling plan, and all these things are there. Now, when you want to basically measure the number of defects and whether they pass the quality control based on the stopping criteria for the sequential sampling plan, if you look at the graph, which is 15.16 based on the book which is Montgomery, where we have said time and again, and I have said repeatedly, is an excellent book. So, we are taking the diagram from that. So, you are trying to measure n along the x axis, n the number of observations, and the number of defects are given. So, this is between a band. So, if it is plus minus some numbers, you will basically accept that. If it is more than that, less than that, you will take a decisions accordingly. So, obviously, less than that you will definitely accept, more than becomes a rejection. Now, this is a sort of control limits in, so as to say, but the control limits which you see in statistical quality control are horizontally drawn on the graph paper, but this would be a little bit tilted because as the sampling size increases, obviously, the decision whether to accept or reject would be taken accordingly. So, in one case you have basically the upper control limit is H2 or a function of N2 plus the number of total cost which you have for accepting n number of observations, and in the other case it will be H1 depending on a function of N1, you will basically have that cost which is Sn. And as you consider this these heights which are given as H1 and H2, so that will depend on the number of defects which you are considering. Obviously, that would depend on the sample size also. So, if you pick up 100, you have some probability that you think that value C, if you remember, which should be the average number of observations or objects which are there which are defective. Similarly, you will take a decisions accordingly as N2 changes, which is more than N1 or less than N1. Now, here the word N2 I am not meaning the total combined sample size. If in double sampling we have considered N2 as the sum of the number of samples which you consider in the first go plus in the second go. Here I am using N2 word as distinctive from the definition of the combined sample size. N1 would be only for the first sample, N2 would be for the second sample, and accordingly. Now, if you consider H1 and H2 which are plus and minus 2 defects in that lot, so obviously you would have a band between which the acceptance and out of that the rejections would be done. So, rejections would be done if it is more, obviously below that, which means it is better, or the number of defects are less than that number which is stipulated, or obviously we will always accept that. So, if I go to this, so in this region all will be rejected because the number of defects which you have would definitely be crossing that. So, in that case whatever the sample you pick up, if it is crosses that, you reject it. And if I use another different color shading, let me change the color to red. So in this portion it is acceptance. So if you see the word acceptance here. Now let me come to the concept that how this is tackled. Let me choose the black color. Okay. Now you take 10 observations and then you find out the number of defects is something. So this is, say for example, the number of defects, and it is within this band which I am not highlighting, what I am showing. So you accept. Then you take some next set of observations. So this is the next set of observations. It goes to, say for example, 13, and again you check the number of defects are, initially it was this height, now it is this plus this, you again accept. So as you continue going in this direction, there may be some regions, so this I am extending, there may be the regions where if you go in the nth set of picking, this nth set of picking is not the sample size. So make it, to make it clear, let me make it, say for example, m. So m number of such observations are being picked up. So in the case when the mth one is there, so this is the first, and then you have the second. If you continue, this is the mth one, and on mth one the total number of observations would be summed up from here till the mth stage. Total number of defects are along the vertical axis, as I have mentioned a little bit time ago, and if the number of defects are crossing onto the upper part where the yellow color is, so you reject. If it is below, you accept it. So this can be extended for different type of sequence sampling plan, depending on whether you take one observation at a time. It is like this: n, then n plus 1, n plus 2 continues. Another can be n plus, say for example, m. This m and this m are not equal. M is the number of observations you want to take, and how many such sets you want to take, that is by r. So it will be m r plus, then the next round becomes m r 1. So r 1, r 2, r are different. So it is like this. If I draw a straight line, so basically I make a jump of n observations, then basically I start making the jumps accordingly, where the number of observations are basically where the highlighting points are in black color. So you continue doing this and you accept and reject. So this is a intuitive feel which I am trying to give for the sampling or sequential sampling plan. Now the sequential sampling plans, as per the general agreed upon norms, is that the acceptance lines would be, one would be minus h1, that is the lower portion, plus s into n depending on the cost structure. Another would be above, which will be h2 plus s into n. So obviously h1 and h2 may differ, may not differ, depending on how the problem has been stated. So obviously this h1 and h2 have been already decided upon, and they are given by the corresponding the formula. So I am not going to discuss the formulas, only remember this alpha and beta would be the alpha beta which we are already discussed when we were discussing the OC curves. So there are different type of military standards also. So these military standards are as per the book, which would basically be used in the concept of the US Armed Forces. So description of the standards are given like this: sampling procedure for inspection by attributes developed during World War II are being used, and they were developed in a very big way. And it is the most widely used accepted sampling system for attributes in the world today. So based on how sampling could be done, how rejections could be done, how acceptance could be done in World War II, they have been taken for the industrial purposes only, that means for manufacturing concepts, not for the service sectors. So collection of sampling schemes have been described in detail, therefore an acceptance sampling system has been proposed. Provides for three types of sampling: either you can take single, you can take double, or you can take multiple. Multiple obviously would come in under collectively as the sequential sampling plan. Primary focal point is the acceptance quality level of the AQL level or LTPD concept, which you have considered in the OC curves. Different AQL may be designated for different types of defects. It can be critical, it can be major, it can be minor, it can depend on the distributions. Those critical, major, minor would also depend on what type of products you have. Say for example, I am using some component which is used in a pacemaker for the heart, or I am trying to use some material or some product which is being manufactured. I want to test the quality of that. They would be used in aircraft engines, or they would be used in critical bridge making. So, obviously, the level of quality inspection and the quality levels would be much higher. In case, say for example, I am trying to utilize some material to make a chair or a table, in those levels concept of quality would definitely be there, but the critical level and the emphasis would definitely be different, because you have to understand the critical level based on the cost component and how good or bad the effect would be depending on their failures. So, generally specified in contract or by authority responsible for the sampling. So, it is already predefined. Sample size is determined by lot size and by choice of inspection level or the plans which has already been decided or predefined. So, continuing the military standards, for a specified AQL and inspection level and a given lot size, this military standards provides a normal sampling plan that is to be used as long as the supplier is producing the product at the AQL level or better. It also provides a procedure for switching to tightened and reduced inspection norms wherever there is an indication that the supplier's quality has changed. So, in case this quality has become bad, so obviously you have to be cautious. In the case the supplier's quality is turning out to be good, you would not relax, but obviously the overall emphasis on the major, minor risk and the level of importance you will place would definitely be not up to that strict level. The switching procedure between normal, tightened and reduced inspections are illustrated graphically in that book, where the figure is 15.17, but we will just discuss them in words. So, when you are going from normal to tightened, when normal inspection is in effect, tightened inspection is instituted when 2 out of the 5 consecutive lots have been rejected on original submissions. So, 5 out of the 5, 2 have been rejected, that means there is some problem, you should take immediate action and basically tighten your norms of inspection. When you are going from tightened to normal, when tightened inspection is in effect, normal inspection would take precedence and would be replacing the tightened one if when 5 consecutive lots, none of them have been found to be defective or they have been accepted. If you are going from normal to reduced, when normal inspection is in effect, reduced inspection is instituted provided all 4 of these conditions are satisfied, which is number 1, the preceding 10 lots have been in. So, these are specifications like 10 or 12 or 13, whatever is mentioned it is based on the military standards. The preceding 10 lots have been on normal inspection and none of the lots have been rejected on original inspection. So, that means you are changing from normal to reduced. Another one of them would be that all 4 have to be satisfied. The second one would be the total number of defects in the sample from the preceding 10 lots is less than or equal to the applicable limit number specified in the standard. Production is at a steady rate, that is no difficulties such as machine breakdowns, material shortage or other problems had recently occurred. So, obviously, they would be considered in as one of those 4 points based on which the normal to reduced inspection concepts can be utilized. And the last one being reduced inspection is considered desirable by the authority responsible for sampling, because that would basically reduce the cost, but something has to be remembered that if you reduce the cost, the level of inspection or the probability of faults occurring or you are missing the faults which you cannot catch may increase, but a compromise has to be made depending on what is your cost structure, what is your efficiency, what is your robustness and sensitivity of this different type of sampling plans. To continue further with the military standards, reduced to normal can all be used when reduced inspection is in effect. So, you are now basically changing from reduced to normal. So, if any one of the following 4 conditions are applied, that was a union set, now it is an intersection, any one of them. So, minimum any would satisfy, you will basically take it. A lot or batch is rejected when the sampling procedure terminates with neither acceptance nor rejection criteria has been made, and the lot or batch is accepted, but normal inspection is reinstituted starting with the next lot. Production is irregular or delayed, other conditions warrant that normal inspection should be instituted due to some reasons which are definitely not positive. Discontinuance of inspection would happen in the event 10 consecutive lots remain on tightened inspection. Inspection under the provisions of the military standard codes should be terminated, and action should be taken to at the supplier's end to improve the quality of the products which they are supplying to the military, because the reason was military needed absolutely zero error objects or materials or products. So, obviously, the standards were based on that, and they were very strict, laid down very open norms based on which the supplier, once he or she agrees, those procedures had to be followed. So, if you see the military standard, the switching rules based on whether you want to go from reduced to normal, normal to reduced, then in the nutshell what I discussed is basically given as a diagram. So, there are some AND conditions and OR conditions. If you remember, I said something to do with the union and some would be the intersection of the minimum one. So, that would give you the picture that the AND conditions are there where my finger set of left fingers are, and here the OR conditions are given. So, AND conditions and OR conditions are mentioned. Depending on that, you can go for tightened and tightened norms also, or you can go for normal to tightened or normal to reduced. And in case if some scrapping of the norms have to be done, you will do accordingly, but there are certain procedures how you go about that. So, obviously, all these are laid down, they have to be practiced, and then once you understand, you will be able to appreciate how the norms are taken. This I have just given you a theoretical flavor to give you how the norms are basically laid down and what are the general procedure based on which you will take the decision. So, the procedures for the military standards would be you check the AQL model, you choose the inspection level. So, at what level you want to do, you obviously have to determine the lot size, because that will determine what is value of C, and that will also determine what is the total cost. Find the appropriate sample size, determine the appropriate type of sampling plan to use, enter the appropriate table to find the type of plan to be used, and determine the corresponding normal and reduced inspection plans to be used when required. So, if you consider all these things, tables in the book like 15.4, 15.5, 15.6 and 15.7 will give you some idea about the different type of rules based on the inspections plans from the military standards. So, to continue the tables, I will just discuss the tables, they are already decided. So, I will only highlight what are the measurements which are being made. So, this sample size code letters are given. So, the lot size which are given on the leftmost column, they start from 2 to 8 and go till 5 lakh 1 and overrun that, and then you have the special levels which are given by levels of S1 to S4, and general inspection levels are given from 1 to 3. So, you will basically choose the combinations and make the decisions accordingly. So, several points about military standards should be emphasized, which are that they emphasize on the AQL orientation problem, and not all possible sample size are possible. So, if you remember, if small sample size are there like 2, 3, 5, 8, obviously at the boundaries it may not be possible to take a decisions accordingly based on the military standards. Sample size are related to lot size. So, bigger the lot, bigger the sample size, smaller the lot, smaller the sample size, because cost effects, efficiency effects obviously have to be considered. Switching rules are subject to criticism for both mis-switching and not on, and whether you want to switch when it is not allowed, or you do not want to switch when it should be allowed. So, obviously, there are criticisms. So, obviously, in some sense they would give you some idea that there are lots which should not be rejected, but you reject them and vice versa. So, that will give you some informations or bring a simile between the consumer risk and the producer risk. So, obviously, that will come because there is a supplier and a vendor. So, or a set of customer. So, the customer are the military people or the military installation, and the suppliers or the vendors are the suppliers for those products, on whose products you will do the sampling plans and the sampling inspection. So, obviously, a major not a problem which is a part and parcel of the military standards, but it does happen that the switching happens quite often, which basically breaks the overall scheme based on which the military standards had been developed and they are used. So, obviously, rather than blaming on the overall inspection process which is taken care on an individual basis, people are tempted to blame the military standard, which are structured norms. So, if you follow them, they obviously they should give you the results, but if you try to basically bypass them, then the problem occurs, for which rather than blaming the military standards, we should try to analyze the where the such breaking of the rules have occurred or do occur. So, now you have the Dodge-Romig sampling plan. So, Dodge and Romig developed a set of sampling plan inspection by lot inspections. So, of products by attributes, that the characteristics, using two types of sampling plans, plans for lot tolerance, which is LTP, the concept of the in the QC OC curves which you considered, and the AQL or AQL levels. For each of these approaches to sampling plan design, there are tables for single and double sampling. Obviously, those concept of accepted sampling which we considered was single sampling, double sampling and multiple sampling. Sampling plans that emphasize LTPDs such as the Dodge-Romig plans are often preferred to AQL, and particularly for critical components if you remembered where the sensitivity or the level of acceptance absolutely have to be perfect. Many manufacturing believe that they have relied too much on the AQLs in the past, and they are now emphasizing other measures of performance such as defective parts per million and so on and so forth. So, if you consider the equivalence conversion between AOQL or AQL and defects parts per million, so that is given in this table which is part and parcel of sections 15.5. So, on the first column you have the AQL value starting from 10% going to 0.0001 percentage, and on the right hand column you have the defective parts per million. So, you can make a 1-to-1 correspondence and take the decisions accordingly. Thus, even very small AQLs imply large numbers of defective parts per million. In complex products, the effect of this can be devastating, and they would be shown in different type of examples which are already discussed in the book. So, based on that, we will understand that what would be the PPM conversions based on the fact of what is the AQL values, and on the conversion concept between AQL and the PPM, you will take a decisions accordingly, that what is the sampling procedure or the plan. AQL plans, if you basically summarize the bullet points, would be Dodge-Romig gave in 1959, gives the AOQL sampling plans for specified AOQL values. 6 classes of values for process averages are specified for various lot sizes. Tables are available for both single and double sampling, designed so that average total inspection at a given AOQL and process average is approximately minimum. And if you go to the LTBD plans, so Dodge-Romig LTBD tables are designed so that the probability of lot acceptance at the LTBD value is given as 0.1. So, obviously, there would be a 1-to-1 correspondence between the PPM and the AQL and the LTBD values. 6 classes of values are there for process averages, and examples are given in details in the Montgomery book. So, important terms which we are considered is 100% inspection, AQL value, AOQL value, attributes, sample size, average total inspection, Dodge-Romig plan, sequential sampling, single sampling, double sampling, then OC curves, lot size sampling plans, multiple sampling plans, which is the sequential sampling one, and so on and so forth. So, guidelines for using acceptance samplings are: an acceptance sampling plan consists of sample size and accepted rejection criteria for lot sentencing. An acceptance sampling scheme is a set of procedures consisting as acceptance sampling plans in which lot size, sample size and acceptance rejections criteria along with the amount of 100% inspections are related. A sampling plan is a unified collection of one or more scheme based on which you will do the sampling. So, if you consider the accepted sampling plans, in the topmost row you would have a basically a objective and why you are doing that, then you have the attributes procedure and you have the variable procedure. So, one set of characteristics which are subjective in nature, some concepts like the color is not good, whatever it is, or the decibel level is high based on some that, and others are actual quantitative values which will definitely define as the variables concept. So, if you want to assure quality levels for consumer and producer, which is the first point which is mentioned in the leftmost column, then the attributes procedure and the variable procedure would be select plan for specific OC curves, and you will do it similarly for the variable procedure curve also. So, if you go along the first column, they would be maintain quality at target, assure average outgoing quality level, reduce inspection after good quality history, so on and so forth. So, if you check the corresponding attribute procedure and the variable procedure, you will cover the whole range of decisions based on which this mapping can be done, or the analysis of the accepted sampling procedures can be done. Now, with this I will come, I am not switching the topic, but with this I will come to the very brief introduction of R. R is a very useful software which is freely available, downloadable from net, and those library functions are being expanded on an exponential basis daily. And once you are able to understand the general concept of R, I am not going to go into the details of R, I will just mention the main procedures based on which some of the problems have been worked. So, I will request, urge and plead the students that whether required for this course or not course, that is immaterial, but do please pick up R as a topic which you can utilize in different spheres, not only in statistics, not only in operational research, you can use in different fields also. So, R is an integrated suite of software facilities for data manipulation, calculation and graphical display. So, obviously, the graphical interface is decently well, you can formulate different graphs and get the outputs accordingly. R will be used in drawing control charts, drawing probability distributions and etc. for this TQM1 course. Discussions will be limited to what is required for this course only, which I mentioned. So, I am not going to overstep and basically continue the discussions in R, because the discussions in R can be itself a course in nature. That means, people would be more interested to take R and they can apply R in any different fields. It can be statistics, it can be optimization, it can be maybe you are trying to use in engineering and so on and so forth. So, to install R, one can open the cran.r project. So, you can find out the link as it is given. Once R is utilized, we need to install the Art Studio. So, installing the Art Studio is very helpful because it becomes a very user friendly interface with the computer and you. So, you have a screen with different windows and you can basically type your command, get the results accordingly and try to understand how it looks like. So, then remember R is a case sensitive package. So, if you are writing the codes in R, you have to be careful accordingly. I will come to the few details later on. So, which means that small a and capital A are not equal, or capital A small s are not equal accordingly. So, creating and storing the R files would be R creates the .r files. So, the extension is given like this, like in Word document you have doc or .docx files, in Excel you have the .xls files and so on and so forth. In MATLAB you have the .m files. So, it creates the .r files in R which can be saved at the location or drive specified by you. To create R file, you basically go into the file, new file is created and the R script can be opened. To save the file, you basically press Ctrl S as you do in general one, or you can go to the menu, follow the procedure, save it in the directory which has been specified for you. I will continue in the discussions of R in a little bit more detail as required, and with this I will end this lecture and continue with this 20th lecture later on. Thank you, have a nice day.